Recording started. Now let me share my screen. All right, today's topic, we will talk about the medium voltage overhead distribution networks. In this course, what we discussed so far, we talked about the distribution, the overall in distribution. We talked about the substations, and we most likely talked about high voltage substations. Then we talked about transmission. After that, inside the transmission, we talked about high voltage and extra high voltage. That's what we did so far. After that, we talked about the transformer, and most likely we mentioned about the power transformer, distribution transformer, CT, VT, etc. Then we mentioned about the cables. On the cables, we focused more on high voltage cables, but we discussed also low voltage and medium voltage cables, which is we call it underground cables, or in other words, which is called UGS. Now, today's topic, we will try to finish the overhead, because here when we talk about extra voltage, it was overhead before. Now, we will talk about overhead also as well, overhead systems. But we will try to finish it by discussing the medium voltage. Then next lecture, inshallah, on Tuesday, we will talk about overhead systems as high voltage, as low voltage. Then here we can say like we're done with the overhead systems. So high voltage, extra high voltage, medium voltage, and low voltage. So most likely, again, today's topic, we will talk about an example in Jordan that we see a lot in Jordan. And again, we will focus on medium voltage. And as we know, medium voltage is associated with subtransmission. Subtransmission. And in the subtransmission, most likely in Jordan, it is belong to the distribution company. It depends on the location. Like if you are in the north, will be with ITCO. If you are in the middle, JIPCO, or in the south, Jordan Valley, and east, which is with ITCO. Okay, so again, medium voltage as an example. These poles, these medium voltage poles that we can see everywhere. As we mentioned earlier, when you are going to the downtown or inside the cities, you will see the medium voltage poles. I mean, you will not see the medium voltage poles. There will be underground cables. While outside of the cities or outside of the downtown areas, you will see these kind of poles. These kind of poles are called medium voltage poles. And they can be either 33 kilovolts or 11 kilovolts. That's in Jordan. I think maybe there is maybe few lines, 66 kilovolts, but maybe 6 kilovolts are no longer in service. I'm not sure if they are still in service or not. But I would say the main voltage here in medium voltage, which is either 33 kilovolts or 11 kilovolts. Now, the main components of the medium voltage overhead networks, as showing here, poles, the poles that we have, the conductors, or wires, whatever you want to call it, insulators, the insulators like can be glass or porcelain, whatever, strays for the tensioning the devices to make sure, as we know, there's tension and suspension. So we need to have the stays as well in terms of there is an angle or terminal pole, then we need to use this. Cross arms that can carry the, I would say like the insulators and the cables. Substations, I would say like these very small substations that's converting medium voltage to low voltage. We will discuss them here. So specifications, the poles. Again, as we know, the poles are being used to carry the wires or to carry the conductors. So we just like carry them. That's what we want. That's our purpose or our target is to carry the conductors, support and carry the electrical wires. And it has its accessories to do that. Now, however, like regarding to the types, we have two types. There is the concrete poles and there is a steel poles as well. Here are the specifications of the concrete poles. So we can see the length. There is 10 meters up to 15 meters. Which one should we use depending on the place? Sometimes if there is like mountain or a valley or whatever, there is elevation, change in the elevations, then you will use different lengths. So each length has its own bottom diameter, has its own load capacity, and the foundations as well, specifications as we can see here. So we can see like the width and the length of the foundations almost the same for all, and the depth of the foundation as we see here, they are fixed. Then when you look at the weight, of course, the larger length, the larger weights, of course, and the larger diameter as well. However, when we look at the load capacity, it will be decreased. Why it's being decreased? Because the weight is increasing, then it will make a bad impact on the load capacity. Here is how the concrete poles look like, which is they are made of concrete. We can see them a lot around us. So here are like, there is the tension, this is the suspension concrete poles, and they're used to carry, again, the conductors. Here is how it looks like depending on the length. So almost the first 10 meters is the standard or standard. Then whatever we have after this 10 meters, this is the standard. After the 10 meters, all of them are extra length, which is very similar to when we discussed on the high voltage towers. We said that there is, for example, DL plus 9, we say plus 9 is depending on the extra length. So we have the standard is 10 meters, then we have plus 1, plus 2, plus 3, plus 4, up to plus 5. That's, I mean, the thing about it. Now there is another type which is called steel poles. Steel poles, you can see that the thickness is smaller compared to the poles here that we have in the concrete poles. The here's like the steel poles looks like. That's how they looks like. Then you can see it here. Then here's a single pole. When we use, like when you can look at it, there is double pole as we see here, and there is, here's like a double pole, then this one a single pole. Now we will say that when should we use the single pole? Single pole use when the angle below than 10%. If the angle is below than 10%, then it will be fine. We can use single pole. However, if the angle more than, 10 degrees, I'm sorry, not 10%, but I mean 10 degrees, if the angle more than 10 degrees, use double pole, which is two poles. That's the first thing. The second thing, if you have a substation on the pole, then we'll use a double pole as well. So there are two cases for the double pole, which is if when we have a substation or when we have the angle more than 10 degrees. What do I mean by when we have substation? I will talk about it later here in today. So here is double pole, or sometimes they call it H pole. So at the H pole, usually the distance is 2 meters, but we can make a distance between the poles 2.5 meters if you are at the beginning or at the end of the substation or at the portable substations. I mean, the beginning of the line at the end of the line, and if there is some small substations, which is basically when there's a distribution transformer here, there's a distribution transformer here, we will use 2.5 meters. However, if you are I would say below than 10 degrees, then basically we will use single pole. If you are the distance is not at the beginning, or there are some angles, then you use 2 meters. Here's like again double pole, sus suspension. So this tension, tension. This is tension as well. This is suspension. Then this is single pole tension as well. So I would say, to summarize it up, single pole is used when deviation below than 10 degrees, and also in suspension. Double pole, 2 meters, when angle larger than 10 degrees. How about double pole, 2.5 meters? It's been used in 3 cases at the beginning of the line, or at the end of the line, or it can be at the substation. We call it portable substation, or in other words we can say at distribution transformer substation, which is a small substation when we have the distribution transformer. Then these are the cases of the poles, etc. Earthing of poles. All medium voltages are grounded using a grounding strip, which is a thickness 4 times 40 millimeters. So there should be a ground that must be grounded. 4 times 40 millimeters, or a copper wire. So it can be either grounding strip or copper wire. The ground is placed inside the pole, and the top of the wire is connected to the cross arm, and the bottom is connected to the grounding rod, such that 1.2 meters to 16 meters, that's driven into the hole. And that's how, what do I mean by this? Assume you have a double pole. So each pole is grounded. You look, here's at the ground. This is a ground, which is go inside the hole, inside the pole. Then the same one here, inside the pole. And the ground wire keeps going inside the pole to the end of the foundation. Here. Here's the ground level. Then it goes here. It goes here. That's the grounding. So all of these poles are grounded, no matter if they are concrete or steel. All of them, they must be grounded. Here is the ground of the single pole, almost the same concepts. Here's the ground level, then it goes here, hole in the tape case, and you need to reduce the earthing resistance, so we can control the earthing resistance as well from there. Okay, finishing components of the medium. So there is anti-climbing device, of course, and there's a danger plates. There is a number plates. Those are very essential. So there is anti-climbing device. So basically, when you look at the pole, there should be anti-climbing like this one. This is anti-climbing. Then here is not clear. Anti-climbing is not clear here, but there should be anti-climbing somewhere here. But here's this picture shows the anti-climbing in clear way. So here's anti-climbing, and there's a danger plate as well. This is a danger plate, or a warning sign, whatever you want to call it. Danger. Danger plate or warning sign. Then should be also a nameplate as well. Maybe somewhere else should be a nameplate. All right. Now, here is like how the anti-climb looks like. It's very similar to what we see before. Then here is the danger plate as well, how it looks like. This is the standard of it, which is made from steel plates. Then this is the number as well, the number plates, which should be attached to the tower. Now, let's talk about the conductors. The conductors are used, as we know, to transmit the electricity from the substation to where the load. Then we need to make sure we have a good conductors. The very first one, all aluminum alloy conductor, so which is called AAAC, which is made of 99% from aluminum, 20.5, 2.05 from magnesium, then there is 3%, almost 3% from silicon. In Jordan, we have two types. The first one, which is called hazel, the nickname is hazel. The second one, oak. Let's recall when we discussed the medium, the low, high voltage, we mentioned, I'm not sure, do you remember what was their names? Um, I think there was something called Yeo, and there was something else. Actually, I forgot. What's the other name? The name of the conductors depending on the cross-section area. I believe there was Yeo, and there was, actually, I forgot, but there's another one. Here in medium voltage, also there's a cone brand names. There is hazel and there is oak. Each one has its own cross-section area, its own amperes rating. So you can see the larger cross-section area, the larger ampere rated, and also the larger breaking load force. So we can see that there is a mechanical limits and there is an electrical limit here as well. Okay, so the electrical limit related to the rated current, mechanical limit related to how much force it can handle. That's why we call here kilogram force. This is how oaks looks like, and hazel from all aluminum alloy conductor. Again, this is called when we talked about all aluminum alloy conductor, which can be either oak or hazel. Hazel 50 millimeter square, oak 100 millimeter square. Again, it's called all aluminum alloy conductor. So you will see here 1, 2, 3, 4, 5, 6, 7, made of 7 strands. That's what you need to think of, to worry about, which is 7 strands, both of them, oak or hazel, 7 strands. Again, why we have strands? What's the point of making these strands? To avoid the skin effects. Without strands, skin effects, or I would say using strands to reduce the skin effects. Use strands to reduce the skin effects. Now, what do I mean by skin effects? What's the, anybody knows? What does skin effect mean? If you know, please speak. You can answer. Skin effects means on the conductor, the electrons likes to be at the edge of the conductors, which makes the current will flow at the edge of the conductor, not inside it. So if we use a very big cable like this, so you will see the electrons are condensed here, while in the bottom almost empty, almost none. I'm not the bottom, I mean inside the circle, almost none. So to avoid this, we use strands. And when we use strands, you will see the currents or the negative will be at the edges. So as we see here, the current at the edge, the current at the edge, the current at the edge, the electrons are at the edge. So, and when we use this, what I mean, the skin effect will be minimized. Therefore, the currents or the conductor can carry more currents. So if we use one strand, the current can carry less currents, even with the same, I would say, radius. But if you increase, or the same section area, but if you increase or make it strands, then it will be, skin effect will be great. The other thing, keep in mind, these 7 strands are twisted. All of them are twisted. And remember, this is all aluminum alloy conductor, which is made of from 7 strands. Now there is another 2 are being used. So they are related to aluminum conductor steel reinforced. Aluminum conductor steel reinforced. And I think we already mentioned this, something similar to this, and when we talked about the high voltage, there was all aluminum alloy conductor and there was aluminum conductor steel reinforced. Then we can see there are 2 types. There is rabbit and dog. So the rabbits and dog. The rabbits, the cross-section area around 50 millimeter square, while the dog, the cross-section is 100 millimeter square. Then we can see like the current limits is increased when we increase the cross-section area. So an aluminum conductor steel reinforced, the steel has been added so it can handle, increase the mechanical strength of the conductor. So you compare between this one and the previous one. Here was a combination between aluminum, magnesium, and silicon, while here there is a steel reinforced, while the outer is or the outer is, the inner is steel, while the outer is aluminum. Then when we look at it, you will see that there is different things between rabbit and dog. Dog, which is 100 millimeter square. Therefore, what you will see, there are 1, 2, 3, 4, 5, 6 aluminum strands. And there is 1, 2, 3, 4, 5, 6, 7 steel strands. However, when we talk about rabbit, there is 1, 2, 3, 4, 5, 6. This is made from 50 millimeters square and made from 6 aluminum strands. And there is 1 steel strand. So look at the difference between dog and rabbit, which is something can be kind of different than the previous case. In the previous case, no matter if they are, which is called oak or hazel, they are 7 strands, just that's it. However, in this scenario, if it is dog, there is 6 outer aluminum and 7 steel. While if when we talk about the rabbits, which is smaller thickness or smaller radius, or I would say like the cross-section area is lower, then we have only 7 aluminum strands and 1 steel strand. Okay, that's something you need to know and to understand the importance between them. Ground clearance. Ground clearance, which is basically the minimum vertical distance between the lowest point of the overhead electrical conductor to maintain a safe distance. Why? What's the point? It's very important for safety and preventing accidental contact with electrical components. So again, we need it for safety for people, animals, or any other objects that they don't contact with live electricity conductors. The other thing, compliance with standards, because different regions have regulations regarding minimum grounding clearance for overhead transmission line. So we need to make sure there's something related to urban area or rural area, depending on the infrastructure as well, the type of infrastructure. Environmental protection, clearance prevents interference with natural features such as trees, minimize the risk of accident caused by environmental conditions. Sometimes You can see like wind. The wind can move the tree branch. The tree branch can touch the electrical wire, cause a fault. Or the tree, or they can be like a snow. The snow can go to the tree branch, then they will be broken, then they will be falling down to the power lines. Therefore, we need to maintain a safe distance to avoid any of this. Now, how is the clearance looks like? How it's going to be? The clearance can be in medium voltage. We have again in medium voltage we have two voltages, 11 volts and 33 kilovolts. So when we are talking about the car passage, about 5.8 meters. How about when we talk about the pedestrian passage, 5.2 meters. Then how about for 33 kilovolt, almost the same. So that's the standards. I mean, if it is below than 5.8, I mean, it will not kill you. It will not make damages, but the standard, they make it like this. So as a backup, they add extra length. So however, I would say in 11 kilovolt, the length, maybe 1 meter, something like that. But I mean, we're not talking about the electrical safety, but we're talking about some mechanical safety or some other hazards like tree or cars or something going out from the cars or going out from the trucks, especially like the trucks. We need to make sure there is nothing can touch the wire or can go very close to the wires or the conductors. Now, let's talk about the insulators. We already mentioned the insulators before in the high voltage. So we mentioned that the insulators function. There are two functions. There is the electrical function and there is a mechanical function. The electrical function to insulate between the conductors and the poles, while the mechanical function is to carry the conductors and can handle the mechanical force. Then we already mentioned about the type of insulators. I think we are repeating the same thing, but here it's just in medium voltage. There is, I mean, porcelain insulators. There's a rubber or polymer. There is a glass insulator as well. So the glass insulator is most likely used in harsh condition or in the deserts, while there is the porcelain is suitable for medium and high voltage, and it is used in towns, while the rubber is more flexible because it's lightweight, it's resistant to economic like pollution. It doesn't require a washing, while the glass and polymers, both of them requires insulation, or both of them require insulation washing. Insulators washing. Now, also regarding the type of insulators we can classify, we mentioned this before as tension and suspension. Here, we will have something similar to tension and suspension, but we will call it as post insulator or pin insulator. Post insulator, which is something similar to suspension, which can be in vertical position for the pole, similar to suspension. Pin insulators are directly used to the poles and suitable for holding conductors in a place while providing electrical insulation. Then each type of insulator for specific application ensuring electrical safety and mechanical support depending on the voltage level. Here's again how is the glass and porcelain insulator and rubber. So we can see that this is a glass, this is porcelain, and this is rubber as well. The good thing about glass and porcelain, both of them, they have a high lifetime, or I mean, the lifetime is high, and they are cheap, while the rubber or the polymer is more expensive and the lifetime is low compared with the glass and porcelain. The problem with the glass and porcelain, which is they require insulation washing. Here is how the insulators looks like. We can see the number of discs depending on the voltage. So number of insulation discs in 33 kilovolts. Of course, they are larger than is larger than number of discs on or in high voltage in 11 kilovolts. So when you increase the voltages, the insulation discs will be increased, of course. Here's like the post insulators again. As we said, it's very similar to suspension. And most likely you will see it in single pole. Then here is how they look like the pin insulators, like this, the pin insulators. Then the disc insulators and the pilot insulators. The disc insulators, which is most likely they are used on the starts and angle of the sections, which is again, this is very similar to the tension or like angle. We used to say in high voltage as tension tower or angle towers. Now here we call it disc insulators or disc poles. Pilot insulators. So those are making jumpers for connectors, connection between the network and portable ground equipments. What do I mean by portable ground equipments? Which can be either distribution substation, which is again, it can be either distribution substation or it can be another line, making another line, connecting another line as a T, as a T connector. Well, and something we call it like sub-feeder. Sometimes we can call it as sub-feeder. What does sub-feeder mean? Let's recall, assume we have, here's in this substation, that's converting 132 kilovolts to 33 kilovolts. Then here is a feeder, main feeder. Then from main feeder, there is a lateral. Then from that lateral, there is a distribution transformer. So when we do the lateral, you will see the pole here. The type of the poles that insulators that we will use is called pilot insulators. And the same thing here. Because here, when you zoom it, there will be a T shape. A T shape. And there is here as well a T shape. Whenever there is a T shape, then it will be used in pilot insulators. Here is like how the disc insulators looks like. Here is a disc insulator, which is again like tension or angle. Then here is also the tension pole, how it looks like. Here is the suspension again, which is very similar to what we talked about, which is post insulators. Now, regarding the wire height above the ground for the 33 kilovolts. When we talk about 33 kilovolts, there is a pole length, 10 meters, 11 meters, up to 15. We already mentioned this in the previous slides. Now, let's look at the wire heights, phase A, B, C, or we call it 1, 2, 3. Here's like phase A, phase B, phase C. 8.1, 6.8, 5.5, if we are talking about like this one, suspension. Some others, they can be vertically, some of those can be horizontally. This is vertically. There's another one, like can be horizontal distribution. Where is it supposed to be here? There's a vertical and horizontal. I believe in this scenario, it's a horizontal. This is vertical, this is horizontal. In this horizontal, all of them, they are in the same height, while when we talk about the vertical, there is a different heights depending on the manufacturer or depending on the data sheets. Okay. Now the next thing, small electrical substations. What do I mean by small electrical substation? I will say most likely we used to say they are called as DT or distribution transformer. In the distribution transformer, we will call it as a small substation, which is the one that converting 33 kilovolt to zero point 0.4 kilovolt or 11 kilovolt to zero point 0.4 kilovolts. And here is an example, as you see in this picture, of the distribution substation. I mean, this we call a substation. The overall is called small substation. While when you look at this transformer, this is the DT, the distribution transformer. Okay, then you can see it's three-phase. Here is how it looks like. So the first thing that you can observe, there is double pole, and the distance should be 2.5 meters. 2.5 meters, and it is double pole. That's the first observation. The second observation, you can see it is pole mounted. It is mounted on the poles. There is another type which is called the ground mounted, which is mounted on the ground. But this part is pole mounted. Then again, there are two types, or there are several types. The first type, pole mounted, and it is both in the H or double pole, if it is below than 250 kilovolt ampere, if the power exceeds 250 kilovolt ampere, in this part, it will be very big transformer, very big distribution transformer. So you cannot install it on the pole. Then you will install it on the floor or on the ground by making a concrete foundation. The foundation depending on the transformer size, so it will be ground mounted. There is a third one, which is package substation, which is full this integration, fully substation that combines the transformer, switchgear, protection equipments into a single enclosed units. These substations are designed for efficient installation. So you will not see the distribution transformer alone. You will see also some, we call it switchgear panel, like this. Not, where is it? I believe it should be sometime somewhere here. Just we call it the switchgear. So the switchgear, what's inside it? You will see the meters. Then you will see there should be fuses here, because as I said, distribution transformer uses fuses. Those are fuses. I mean, you can go to the distribution transformer close to your neighborhood to know everything, or you get to browse where is it. Here is another distribution transformer. This is pole mounted. The first thing that you can observe, there are fuses here. It is pole mounted using double pole, or sometimes we can call it as H pole. And the distance from here to here is 2.5 meters. Then here is the distribution transformer. There should be a panel somewhere for switchgear, maybe here, maybe this one. We call it switchgear. And the switchgear, it will be basically, you will see what's called, there should be a meters. There should be, I think, some protection like relays as well. Few of them will see circuit breaker, but most likely the distribution transformer, there is the fuses. Again, here is how it looks like, pole mounted. You will see fuses here. Then this is distribution transformer. This is the switchgear. So that's it. This is another sketch for the pole mounted as well, from different side of fuse. The component of the substation, pole mounted or either ground mounted, there should be the following: the lightning arresters to protect the station from lightning when there's a lightning strikes. There is air circuit breaker. This area circuit breaker to disconnect and reconnect the currents under normal conditions. Sometimes we can say abnormal conditions if we are doing maintenance. In protection, we are using fuses for protection. So I would say the aerial circuit breaker, this is manual control. By sending the technician there, we say there's something wrong, then let's turn on and turn off manually. We used to call it, many people call it al-qata al-sikini. So that's, manually being turned on and turned off. However, if there is normal condition like regular maintenance or like abnormals, there's something wrong, then disconnected it. However, in protection, in case of there is overvoltage or overcurrents, or most likely overcurrents, the fuse will work. The fuse will melt, then you can replace the fuse. So again, in protection, we are using fuses. But in like the area circuit breaker, this can be turned on and turned off manually when it is needed. Transformer, again, like distribution transformer. Then connection cables and jumpers. Of course, there must be connection cables and jumpers. Distribution panel. This we have like connecting those to power cables and their protective and measurements device for low voltage feeders. Now, again, when we talk about 33 kilovolts and 11 kilovolts clearance, we already mentioned the clearance when we talk about between the people and the cars passage. Now, how about some others like railway, roadways and streets, open countries, climbed trees, so we can see like the clearance in meters. Now, the other thing, if there is unclimbed trees or building, horizontal building, vertical, must be three, at least three. That's for the 33 kilovolt and 11 kilovolts. Telecommunication bar conductor 1.25 for vertical will be around 2 meters. The aerial telecommunication 1.25. Then the thing about it that we need to think about, which is basically the clearance, which really matters if it is in vertical or horizontal. That's something that we need to think about. Then the other thing, the allowable spans, there is intermediate cross arms, there is angle cross arms, there is long span cross arms. Each one has its own weight limitation and its own maximum spans. So we can say when we say intermediates, this is shorter than the angle section, shorter than the long span cross arm. Then there is the terminal cross arms, the terminal cross arms at the end or at the beginning of the poles. Then there is a special long span cross arms produced by pole planets upon request, which can handle around 250 meters if it is needed. It depends on if it is hazel or oak. Now, the standard size of the kilowatt meters, because there should be a kilowatt meters there, close to the substations and the distribution transformer, and their typical, which is basically the accuracy class. There's a single phase meter, and there's a three phase meter as well. There's the current ratings, and the single phase meter can be either 10 or 20, while in the three phase meter around 25 to 15. The maximum currents that can be handled in single phase, which is 40 amps, while in the three phase can be 60 amps, or bounded between 40 to 80, and here's 60 to 100. Then the voltage rating 220, and I say again, it's no longer used. Now it's 230 volts, 230 volts, and the three phase is no longer 380. It is right now 400 to 230 volts. Then the same thing here, 400 to 230 volts. Okay, so that's all. That's all what you need to know in the medium voltage level. Um, we will talk about the low voltage in the next lecture. But any question? Any question on medium voltage? I hope it's fun because it's fun to understand the poles that we can see them around us nowadays. So inshallah, next lecture We will talk about the high voltage, the low voltage cables, low voltage overhead transmission line. I mean, I believe it will be short also. Next lecture will be short. Then after that, after talking about the low voltage, we will move to overview on the protection, then circuit breakers and auto reclosers and sectionalizers. That's our plan, but let's try to finish the overhead um, voltages. So that's it. Any question? Okay, let me end the recording.